Hi everyone, I'm here today to talk to you about how to interpret a confidence interval. So I have this example up here and it is for the average weight of US males. So I want to know what is the average weight of US males. I can't ask everyone in the population that question, so what I do instead is take a random sample. I took a random sample of 1,000 US males and I got that their average weight was 190 pounds. So when I created my 95% confidence interval, I just took the expected value of the average, which is just the average, 190 pounds, and added and subtracted two standard errors. So the standard error I calculated, you could do that using a formula just like we did in class. The reason that I'm adding and subtracting two standard errors is actually because I want to be 95% confident. This 95%, if I look it up on the normal curve, corresponds to a z-score of 2. The central limit theorem tells us that the probability histogram for averages, which is what I'm looking at, will follow the normal curve quite closely if n is large enough. And it is in this case. N is 1,000. So that's where the 2 came from. So when I solve this, if I take 190 minus the margin of error and 190 plus the margin of error, this is what I get. My confidence interval is 188.8 pounds to 191.2 pounds. And the way that I would interpret this is exactly like this. I would say that I am 95% confident that the true population average, the true average of all US males, falls within this interval, is between 188.8 pounds and 191.2 pounds. So I want to make sure that everyone knew that is exactly how to interpret this confidence interval. A really common mistake that I see, a lot of times people will say, for the interpretation, a wrong interpretation would be this. They would say, does this mean that in my sample, 95% of the people weigh between these two numbers? And that's definitely not true. If you wanted to say something like that, we'd have to go back to chapter 5. So if I wanted to say 95% of people in our sample weigh between what two numbers, I'd have to know for sure that the weights follow the normal curve. And then I know for 95%, that corresponds to a z-score of 2. And I know with the normal curve, with data that follows the normal curve, 95% of the data is within 2 standard deviations of the average. So that's what we talked about back in chapter 5. That's not exactly what we're talking about here with the confidence interval. This is a confidence interval for the average weight of all US males. I'm 95% sure that their average weight, if I ask every single US male this question, their average would fall between those two numbers. One other way to interpret the confidence interval, if this makes more sense, this is another way you could do it. You could think, if hundreds of pollsters, if a bunch of people all took random samples of 1,000 and created 95% confidence intervals, 95% of those intervals would contain the true population average, the true average weight of all US males. If 95% of those intervals would contain the average, that means that 5%, the rest of them, 5% of those intervals would miss the true population average, so would not contain the true population average. And that is pretty much it for the interpretation. So I hope that helps you guys. Good luck studying for the test.